Hello student, this is Dhanjit and you are watching my YouTube channel Reaction Concept. Student, today in this video we are going to discuss a miscellaneous type of topic, that is application of Raoult's law and Dalton's law in an ideal solution of liquid mixture. Okay. Here we are considering an ideal solution of two liquids, that is solute is also liquid and solvent is also liquid here. So in this mixture we will apply both this law, Dalton's law and Raoult's law. How we will apply these things, this will describe here. Okay, and they generally from this topic sometimes question asked, numerical question asked sometimes. Okay, so let us see the topic here. Suppose you have a liquid A. You are having a pure liquid A. So since it is a pure, in this case there will be a vapor pressure of this pure liquid. Suppose this is denoted by PA0. Again you have a liquid P. You have a liquid, pure liquid B. In this case the vapor pressure exerted by this pure liquid, it is PB0. Okay, when we mix these two pure liquid, we will get a mixture of A and B. We will get a mixture of A and B. Okay, in this mixture, there will be A and B in the liquid state. Okay, in the vapor state, there are also some particles of vapor of A and B. So this is vapor state and this is liquid state. This is liquid state and this is vapor state. You see, in the liquid state, suppose the composition of AB is represented by the mole fraction of A, that is denoted by XA, and mole fraction of B. These are the composition of A and B in the liquid. Okay, in the mixture solution, these are the mole fractions. In the vapor state also there will be composition of A and B. This composition of A and B suppose represented by the mole fraction of A and mole fraction of B. Suppose it is YA and YB. These are the mole fraction of A and B in the vapor state. So in order to find out this composition, mole fraction of A and B in the vapor state, mole fraction of A and B in the liquid state, we can apply in the vapor state, we can apply what? Dalton's law of partial pressure. And in the liquid state, since it is already considered it is an ideal mixture. Okay, so ideal mixture, for ideal mixture we can apply what? Raoult's law. From these two law we can find out the composition of A and B in both vapor and liquid state. So let us consider what is Dalton's law for the vapor state. According to the vapor state of Dalton's law, it is said that the total pressure of A and B would be the total pressure, partial pressure of A and partial pressure of B. In this vapor state, the partial pressure of A it is represented by PA, for B it is PB. These are the partial pressures. So these partial pressures PA according to the Dalton's law is equal to multiplication of P total into mole fraction of A in the vapor state. Similarly, partial pressure of B is equal to the P total into mole fraction of B in the vapor state. So these two laws can be applied in case of vapor state, okay? But in case of liquid state, we will apply Raoult's law or ideal solution. So what are the Raoult's law? According to the Raoult's law, the vapor pressure of a component PA would be equal to the multiplication of vapor pressure of that solvent in pure state into mole fraction of that component in the solution. Similarly, vapor pressure of B would be PB naught into mole fraction of B. So these are the two Raoult's law, and these are two Dalton's law of partial pressure. Applying these two laws, we can find out the composition in the liquid state and composition in the vapor state. Okay, these things will be very clear when we discuss some problem. So let us discuss some problem based on this concept. So this is the question, first question based on this application. The question it is saying that there are two organic solvents are considered. One is toluene, this is called toluene, and the other one is called benzene. And it is said that these two liquids are mixed together. When these two are mixed, suppose we are mixing benzene and toluene in the ratio of 2:3. In the ratio of 2:3, we are mixing here. Okay, this is in the liquid state, and it is said that the vapor pressure of benzene in pure state. In pure state, it is given that 80 mm, and vapor pressure of toluene in pure state it is 40 mm. Okay, these are the pressure of their vapor pressure of pure state. So it is asked to find out what is the composition of B, benzene and toluene in the vapor state. Okay, so first we will apply the Raoult's law in case of liquid state. So according to the Raoult's law, it is saying that the vapor pressure of this benzene, is equal to the vapor pressure of that benzene in the pure state into mole fraction of benzene in the solution. So since this value is given as 80 mm, so you can write here 80 mm. Mole fraction, since it is mixed in 2:3 ratio, mole ratio. Okay, so mole fraction can be written as 2 divided by 2 plus 3. So it will result as, this will 5 and 16, this will 32 millimeter of H. So this is the vapor pressure of benzene in the solution. Okay, PB would be 32 mm. Similarly, we can find out P, that is vapor pressure of toluene in the solution. It would be PT naught into mole fraction of toluene. It would be 40 into 3 divided by 5. It would be 24 mm. It would be 24 mm. This vapor pressure of benzene and toluene, these are the partial pressure of since vapor exists in the vapor state, this will be the partial pressure of benzene and toluene. Okay, so total pressure would be PB plus PT. Again, this PB can be written as total pressure into mole fraction of, this would be B, benzene in the vapor state. So mole fraction of benzene in the vapor state can be written as PV divided by total pressure. This should be total pressure. Okay, so it would be PV, what we have got, 32, and PT, it would be 32 plus 24. divided by 56, whereas YT would be PT divided by PV plus PT. PT we have got 24, okay, divided by 56. So these are the composition of benzene and toluene in the vapor state. Okay, you simplify this value. So there is another problem I am discussing here. This is a very important problem. Just concentrate on the method of solution. Okay, very interesting problem it is. So in the question it is saying that there are two solvent are there, A and B. Two substances are there, A and B. Both are in pure liquid form. Okay, when A and B is mixed, we will get a mixture. Okay, and it is said that A and B is mixed first in the ratio of 1:3. 1 mole of A and 3 mole of B. Then in the mixture, the total pressure that is vapor pressure, it would be found at 550 mm. Again it is saying that in the question we add additional 1 mole of B in the solution. That is, the second case we are mixing 1 mole of A and 4 mole of B, and it is said that in the mixture the total vapor pressure of the solution, it becomes 560 mm. If it is so, then what would be the vapor pressure of A and B, that is A and B in pure state? This we have to find out. Okay, so first consider this one as a case 1, this is a case 2. So in the case 1, you see, if we consider the total pressure as a summation of PA and PB, it is 550. Okay, so in place of vapor pressure of A, we can write PA naught into mole fraction of A in the solution, and in place of PB, that is vapor pressure of component B in the solution, we can write PB naught and mole fraction of B in the solution. So we don't know these two values, PA naught and PB naught. You see, first in the case it is mixed 1:3 ratio, so mole fraction of A would be 1/4, whereas mole fraction of B would be 3/4. Okay, if we solve this equation, we will get an equation, linear equation of PA and PB. This would be PA naught plus 3PB naught into 2200. Number it as number 1 equation. Okay, now consider this case 2. Here it is 1 mole of A and 4 mole of B is mixed. So P total here would be PA plus PB. In this case also we can write PA naught mole fraction of A in the solution, PB naught mole fraction of B in the solution. It would be 560. Okay, we don't know the PA naught and PB naught value. So mole fraction of A would be 1/5 and mole fraction of B would be 4/5. So if we solve this, we will get an equation like this: 2800 PA naught plus 4 of P B naught. Number it as equation number 2. Now you do one thing, subtract equation 1 from equation 2. Then you will get this P A naught and P A naught will cancel out. We will have only P B naught. And this would be 600 mm. If you put this P B naught in any of these two equations, then we will get P A naught value. Suppose P A naught value from equation 2 would be 2800 minus 4 into 600. It would be 400 mm. So this is the value. These are the two value we have got, 400 mm and 600 mm. These are the answer. So this is how you have to solve this problem. So we have solved two problems, okay, based on this concept. I hope guys you have understood all the things that I have discussed. If you have any doubt, you can ask me on the comment section below. And if you are new to this channel, then subscribe our channel and don't forget to press the bell icon so that you can get the instant notification from the channel. Okay guys, see you in the next class. Till then, thank you.